Hi, welcome to the sixth functions tutorial titled the Trigonometric Sketch. In today's tutorial, we will be looking at the basic graphs of the functions sine of x, cos of x, and tan of x. We will look at an easy way of deriving the basic sketch, and in the next tutorial, we will look at transformations on that sketch. In terms of what you need to know to progress on with this work, you need to be familiar with your grade 10 work with specific reference to trigonometry. You also need to have gone through the first 5 functions tutorials. We will begin by looking at the graph of the function f of x is equals to sine x. We will sketch this graph using the table method. Please note that the table I am about to use is slightly different from the table that I've been using thus far in functions. I will explain later why I do this. My table is going to look like this. My x values, I'm going to start at negative 360 degrees and I'm going to climb in intervals of 90 degrees. It will be negative 360, negative 270, negative 180, negative 90, 0, 90, 180, 270 and 360 degrees. My corresponding f of x values will be sine of negative 360 is equals to 0, of negative 270 is equals to 1, of negative 180 is equals to 0, of negative 90, negative 1, 0, 0, 90, 1, 180 degrees 0, 270 degrees negative 1, and sine of 360 degrees is equals to 0. Taking this table and sketching my graph, we will get the following. Now there are 2 reasons that I chose the table the way that I did. Firstly, I chose it from negative 360 to positive 360 to illustrate one important thing about trigonometric functions to you. Trigonometric functions by their nature are repetitive functions. Notice this sine graph. It has a wave-like nature. It continues to repeat itself over and over again. If I take values beyond positive 360 and move up to 720, I'm going to get another wave coming in. If I look at the negative side and I move from negative 360 to negative 720, again my wave is going to repeat itself. With trigonometric graphs, you do not need to draw out such a long drawn out table. You probably only need to do 0 to 360 degrees just to get the basic idea of the shape of it and sketch it from there. Also, when you are doing the table method, you are welcome to use your calculators for now. I would prefer it if you became better at trigonometry to be able to do this table without using the calculator. The second reason I've chosen my table as I did, you'll notice that I moved up in intervals of 90 degrees. Unlike all of my previous functions tables where I moved up in intervals of 1 or 2, in this case I used the 90 degree increase in interval because sine of 1 is very similar to sine of 2, which is similar to sine of 3. So in order to get any idea of the shape of a trigonometric graph, we'd either need to use a humongous table or we use a table with fairly large intervals of 90 degrees, and you will see later on when we move into transformations of trigonometric graphs that we might even be able to use much bigger intervals. I want you to now have a go at the following. G of x is equals to cos of x. I want you to use the same table that I've used and I want you to sketch that graph. Press pause on your DVD player and when you return we'll go through it together. Now let us take a look at the cos graph. I told you to draw me the graph of cos of x. The table method I'm going to use is x values of negative 360, negative 270, negative 180, negative 90, 0, 90, 180, 270, and 360 degrees. All of those are degrees, by the way. Alright, now let's look at our corresponding y values. This is our x values. Let's look at our y values. When x is equal to negative 360, cos of negative 360 on your calculator should give you an answer of 1. Cos of negative 270 will give you 0. Cos of negative 180 will give you negative 1. Cos of negative 90, 0. Cos of 0, 1. Cos of 90 will give me 0. Cos of 180 degrees will give me negative 1. Cos of 270 degrees will give me 0. And cos of 360 will give me positive 1. If I draw this graph, this time I'm actually going to use a ruler. Start it with 0 over here. Let's make that negative 90, negative 180, negative 270, and negative 360. That's going to be positive 90, positive 180, positive 270, and positive 360. And this is just going to go up to negative 1 and positive 1. Alright, that's y is equal to negative 1, y is equal to positive 1. 0 degrees, 90, 180, 270, 360, negative 90, that's a bit out of shape, negative 180, negative 270, and negative 360. Cos of 0 is positive 1. Let's draw that in a different color. Cos of 0 is positive 1. Or let's start from negative 360. Cos of negative 360 is positive 1. Then it goes down to 0 at negative 270, then negative 1 at negative 180, at negative 90 it's 0, at 0 it's 1, at 90 it's 0, at 180 it's negative 1, at 270 it's 0, and at 360 it's positive 1. That means that my graph looks a bit like this. Notice that its shape repeats itself every 360 degrees, the same as the sine graph. The sine graph repeated itself every 360 degrees. However, the sine graph was slightly, or rather was the opposite to the cos graph, in that the sine graph did that. So the sine graph had that shape, which repeated itself every 360 degrees. Did that. And the cos graph in blue is the one that also repeats itself every 360, but has slightly opposite values to the sine graph. So far so good. Now I want you to have a go at the 10 graph. Sketch the graph of k of x is equals to 10x. But here's the twist. First I want you to use the table that we've been using thus far. That is from negative 360 up to 360 with intervals of 90 degrees. When you get frustrated with that table, I then want you to have a go at this table. The period from negative 180 degrees up to positive 180 degrees and intervals of 45 degrees. When you return, we'll go through the graph together. Now let us take a look at the tan graph. Tan of x is equal to y, or y is equal to tan of x. I'm going to start off using the table method of negative 360, negative 270, negative 180, negative 90, 0, 90, 180, 270, and 360. Now watch the problem. Tan of negative 360 gives me a y value of 0. Tan of negative 270 on your calculator said math error. Tan of negative 180 gave me 0. Tan of negative 90 gave me math error. Tan of 0 gave me 0. Tan of 90 gave me math error. Tan of 180 gave me 0. Tan of 270 gave me math error. And tan of 360 gave me 0. Okay, let's start by sketching in this graph, or by trying to sketch in this graph, and let's see where we come to. Let's make that the middle. Negative 90, negative 180, negative 270, and negative 360. Positive 90, positive 180, positive 270, positive 360. And this is our x-axis, this is our y-axis. Now let's look. The 0 points are easy to sketch in. I'm going to sketch it in red. The 0 points, like I say, are easy to sketch in. 0 at negative 360. Let's just put our points in. Negative 360, negative 270, negative 180, negative 90, 90, 180, 270, 360. 0 at negative 360, undefined at negative 270. That means that that is an asymptote. It cannot reach that. Negative 180, 0, undefined at negative 90. 0 at 0, undefined at positive 90. 0 at 180, undefined at positive 270. And 0 at 360. Look how many undefined graphs we have. Also keep a note of the distance between each undefined point. It's 180 degrees. I can't sketch a graph from this. I've just got a whole bunch of 0 points. What I'm now going to do is I'm going to put points in between each of these. Between negative 360 and negative 270 is going to give me negative 315. Between negative 270 and negative 180 is negative 225. Between negative 180 and negative 90 is negative 135. Between negative 90 and 0 is negative 45. Between 0 and 90 is 45, 90 to 180 is 135, 180 to 270 is 225, 270 to 360 is 315. Alright, now let's look at our corresponding values. Tan of negative 315 is going to give me 1, positive 1. Tan of negative 225 is going to give me negative 1. Tan of negative 135 is going to give me positive 1. Tan of negative 45 is going to give me negative 1. Tan of 45 is going to give me positive 1. Tan of 135 is negative 1. Tan of 225 is going to give me 1. and tan of 315 is negative 1. So now let's look at that. Tan of negative 315 is going to give me positive 1, so that's somewhere over there. Tan of negative 225, which is over there, is going to be negative 1. And then positive 1 at negative 135. At negative 45, it's going to give me negative 1. And notice that this pattern is going to continue. Oh, and it doesn't go past that because we're only sketching it to 360 degrees. Now let's start by looking at this graph here. It's the asymptote there, which means that it comes close to it, but it never quite reaches it. It's going to do that. Let's just make that a bit neater. Basically, our tan graph is going to do that. It's going to come close to our asymptotes, but it's never going to touch them. Notice that our tan graph, it's the same graph over and over again, but it repeats itself every 180 degrees. The tan graph repeats itself every 180 degrees. The sine and the cos graph repeat themselves every 360 degrees. This is the standard tan graph, the standard cos graph and sine graph we've already done. And that brings us to the end of the sixth functions tutorial, which dealt with the trigonometric graph. Again, as with the first 5 functions tutorials, this was only meant to give you a basic idea of the shape of the trigonometric graphs. When we progress on to the next tutorial, titled The Basic Sketch and Transformation, you will see how we can manipulate this graph using different values. Go through the exercise that I left for you in the workbook before moving on.